Hey class, welcome to this week's lecture where we are going to learn about the second half of the water cycle, also called the hydrologic cycle. In this lecture, we will have a one-slide recap as always, and we'll dive right into surface water. Talk about the hydrologic cycle and surface water's place within that cycle. I'll tell you some examples of surface water features, talk about lakes, ponds, reservoirs, and oceans. Then we'll move on to wetlands and glaciers. Next, we'll move on to water basins and terminology associated, then water use and its surface water distribution, as well as discharge, runoff versus infiltration, drainage patterns, fluvial processes, flooding, fluvial landforms, followed by a summary, and then what we will learn for next lecture. So I have included this image again. It is the most recent version of the hydrologic cycle published by the USGS, also known as the US Geological Service. And last week we talked about groundwater. So if you can see my cursor to the bottom of this image, it's everything below the Earth's surface. Now this lecture, we're going to talk about everything on top and at the Earth's surface. So we're going to talk about very briefly lakes and wetlands, oceans and glaciers, as well as reservoirs. But primarily this lecture is going to be about rivers, streams, creeks, as they're essentially the highway for water throughout the system. So some examples of surface water features include lakes and ponds, streams and creeks, wetlands, reservoirs, oceans, and glaciers. And I've included some images here. This image to your upper right is of a pond. They are just typically smaller versions of lakes. Here's a glacier, a beautiful glacier at the bottom here. I've always wanted to go to one simply because the colors look absolutely amazing with the blues of the ice. And then here is a wetland. And this image is particularly of a southern hardwood swamp here in Michigan. So let's talk just briefly on lakes, ponds, reservoirs, and oceans. So these are areas of standing water or also just very slowly moving water. And lakes, ponds, and reservoirs exist in basins or downward areas on land, and they're typically fed by streams, springs, snow, rivers, runoff, as well as direct precipitation into them. And these are all part of something called the hydrosphere, and it's the layer of water that exists at or near the Earth's surface, and this also includes groundwater as well. And the ocean, which we will cover in its entirety in a future lecture, it's a continuous body of water. Obviously, it's very large, and it covers roughly 71% of the Earth's surface. That's pretty crazy to think about. And all of these are important in the hydrologic cycle, as there are areas where water is stored, recharged, discharged, and overall circulated in these particular areas. Wetlands and glaciers. And just so you know, in the future, we will have a glaciers lecture. Wetlands are also called swamps and bogs. I actually live on a swamp, but you might also know them as mangroves or marshes, flats, and peatlands. And these are areas where water collects, and there's a high affinity of flora in these particular areas. These are also recharge points as they can absorb a lot of water. And they are also known as the kidney of the landscape because they filter out so much stuff. Glaciers in particular, they are areas of ice, and they're perennial ice, meaning that they're constantly renewed. So the amount of melting that occurs in these areas is far lower than the amount that is replenished in the form of snowfall. And a crazy thing to think about, glaciers hold 3/4 of the Earth's fresh water. So when you hear about glaciers melting due to climate change and things like that, it's a little scary to think about because we are losing essentially a fresh water source for us. So let's move directly into the stream business. That is the focus of this lecture. So for streams, we have something called water basins. And basins are just like a bathtub for all the Earth's streams to drain into. And it's where they collect into generally a bigger, faster, stronger stream. And all streams want to go to sea level. They want to drain into the ocean. It's not always possible, but that's their goal. So smaller streams are going to flow towards bigger streams, which flow into bigger streams, and you get how the picture goes. So everything is going to flow into this main area that flows out and towards the ocean. So by definition, a drainage basin is how surface water drains into a downward area. You might also also hear it called a catchment or a watershed. Sometimes if you drive along the road, you'll see these tiny signs, such as the one in the lower right, and it's just notifying you that you're now in a watershed, a particular watershed. This one is actually in Kalamazoo on Sprinkle Road, the Davis Creek watershed. And in these drainage basins, this is also where precipitation is captured, and it also contributes to runoff that makes its way into a stream. Now, you might encounter something called a drainage divide. If you go to a place like the Rocky Mountains, you'll come across a point where if you stand on one side of the slope, the water drains one direction into a different basin. You stand on the other side of the slope, it drains into a different basin. What drainage divides are topographic high points, and they just essentially separate different drainage basins from each other. In this image in the upper right, this is taken directly from one of your books. This is what a drainage basin looks like. You see these smaller rivers around the outskirts, or these smaller streams. They're all feeding in like branches on a tree into this main branch here that eventually makes its way to the ocean. And I've included this map to highlight the different major drainage basins throughout the world. Here you'll see what's called the Continental Divide. So that's where I was talking about. If you go to the Rocky Mountains, you can actually get to that and stand on one side or the other. That's just saying water on this side of the divide drains this way, water on the other side drains this way. So there's some terminology we need to go over before we get any farther. So just know when you hear the word tributary, it's a stream that flows into a bigger stream. When you hear the word tributaries in relation to a stream, usually people are talking about the streams that flow into the one that they're currently discussing. So if you hear the word tributaries, that's what that means. Now, as a kind of interesting note, the terms river, brook, and creek are totally social. They're not actual geologic terms. That's why you'll hear me say the word stream going forward for most of the references I'm talking about. But a river is just a large flowing body of water. A stream can be a flowing body of water of any size. It can be a trickle to something the size of the Mississippi River. Brook or creek, once again, it's a social term, not really going to be used in this lecture. It's not really a geologic term. These are very small flowing bodies of water. Now, if you hear the term headwater, that's where a stream begins. Typically, these are areas that are high up in the mountains, higher elevations, a lot steeper terrain. That's typically where streams start. Now, streams that flow into other bigger streams, where one stream ends and another begins, that is considered the headwater for the new stream that it's going into. The mouth of a stream is where it's at its end point. Usually that's at the ocean. That's the mouth of the stream. A perennial stream is one that flows year-round. An example would be the Kalamazoo River. And an ephemeral stream is one that only flows if there's a significant rain event or there was heavy snow melt. You typically encounter these out west. And just know that if a stream does not flow to the ocean, then it is considered part of an endorheic basin. And the only way for water to leave this type of system is through evaporation. So let's talk about water use, specifically surface water distribution. So this map is here to show the relative precipitations in the United States. You'll notice to the west it's a little drier. To the east, it's not so dry. And the 100th meridian is roughly where the average precipitation for the United States transitions from being wet to dry. So global circulation patterns, aka the Coriolis effect, within the atmosphere are factors, or is a factor in the distribution of surface water due to precipitation. So because of the Coriolis effect, as well as uneven earth heating, that determines where precipitation is most likely to fall. Of course, you have local climatic effectors that give more varying degree to how much precipitation an area gets, but that's the general effect to it. So just I added the definition of Coriolis effect just in case you might not remember from school. Coriolis effect is where there's different portions of the Earth that are moving at different speeds relative to one another, and this causes the air currents within the atmosphere to curve across the Earth's surface. So the Coriolis effect plus uneven Earth heating, this causes air to rise at the equator, and it causes it to sink at the poles, the North and South poles, as well as roughly 30 degrees north and south from there. And if you encounter areas that have dry conditions, this is typically where air masses are sinking. If it's humid and wet, that's where air masses are rising. And then local climates, like I said, are further affected by prevailing winds, ocean circulation patterns, rain shadows, as well as their proximity to bodies of water. Where we are at in Michigan, you always hear about lake effect snow. That's because Lake Michigan moderates the type of precipitation we get. All right, that ends video 1 for this week's lecture. I will see you in the next video where we're going to pick up at discharge. See you then.